Alright, today we're going to talk about one of my favorite things in chemistry, which is the periodic table of the elements. And the periodic table of the elements was put together first in its modern format by a Russian scientist by the name of Dmitry Mendeleev. And so what we're looking at today is the periodic table of the elements that he envisioned. When he first put it together, there were only something like 63 elements. And the power of the table and the power of his creation is the fact that it could predict properties about the elements based on where they were in the table. Okay, so just a couple notes on organization. You can see right off the bat that each of the columns has a number over it, and there's a couple different ways to number these things, and I know the video quality on this isn't incredible, so you can't see all the numbers here, but you do have a printout version of this periodic table in your modules tab, so go ahead and print one out and have it in front of you for this video. So each of these columns here are called groups. Groups. They're also called families. So they're either a group or a family, and part of the reason that they're called families is because each of these columns, the elements that are in each of these columns, have specific characteristics in common, just like you have specific characteristics in common with your family. So each of the groups has a specific name, and that specific name gives you information about the elements within it. And we'll talk about that in a second. Now the other part here are the rows. So the columns go up and down, the rows go across, and the rows are called periods. Hence periodic table. And the periods give you information about the way that a trend will change going from one end to another. So for example, if you start at the right hand side of the periodic table on this side and you look at just one row across the periodic table, if you go from right to left, then as you go across with each of the elements, they get a little bit bigger in terms of their atomic radius. So they get a little bit larger as we go from one side to another. So we can get a complete sense of a trend within one row on the periodic table. And so I want to talk a little bit about the organization, and we'll tell some stories about the periodic table and some of the elements, and then we'll kind of go from there. Okay? So with our periodic table, we can divide the table up into metals and non-metals, and there's basically a natural divider between the two groups, and they are right here. I always call them a stair step. So that's B for boron, Si for silicon, As is arsenic. We have selenium here, tellurium, astatine. Okay, so we have some of these guys here. Antimony is usually in there. Okay. So we have this stair step of metalloids here. I forgot germanium. And you'll see here that I have 1, 2, 3, 4, 5, 6, 7 of them identified. These are identified on this particular periodic table. Your book will mention 6 of them. There's a little bit of a debate back and forth on this, but these are called metalloids. Metalloids, or semi-metals. And they're called metalloids because they have characteristics that are metallic, hence the metal part, but the oid part tells you that it's kind of like metal-ish. So it's sort of like a metal, but it's sort of not like a metal. And so it acts as a natural barrier between the two sides. Everything to the left of this stair step of metalloids are metals. And everything to the right of this stair step of metalloids are non-metals. Okay, so we'll come back to this periodic table, but I want to give you some characteristics first of kind of what metals are and what metals aren't. And remember that this metalloid barrier is kind of the way that you can tell the difference. So we'll get some notes here. All right, let's talk about metals. Now you've seen metals before. Chemically speaking, metals aren't that different from the way that you think about metals. Metals are kind of interesting because they're shiny, right? That's That's why we use them for coins. The chemical term for that is lustrous, which means that they reflect the light well, so they're shiny. Metals also conduct heat and electricity well. Remember, heat is the energy of moving particles, so they conduct that heat really well. These moving particles can move through metals more fluidly than they can move through nonmetals. They also conduct electricity, which is incredibly important because that's how we can get electricity to our homes, is it's transferred through metal wires. And the reason that we can stretch them into long, skinny wires is because they are ductile. That's what that characteristic means. It means that they are stretchable. So we can stretch these metals out into long, thin wires, and then we can conduct electricity through them, which is useful. Another characteristic of metals is they are malleable. Malleable literally means that you can smash it with a hammer. It means hammerable in Latin. It comes from malleabilis. But I like to think about it as shapeable or moldable. Hammerable. And this is the reason that we can get metals so nice and thin. So we can hammer them and they get thinner and thinner and thinner and thinner, and then we have this nice thin sheet of metal, and we can wrap that thin sheet of metal around things. So we can get gold, for instance, and hammer it and hammer it and hammer it and get it thinner and thinner and thinner, and then we can cover things like chocolates and toilet seats or whatever it is that you want to cover with gold. Okay, it's because they're malleable. So these are some characteristics of metals. Usually when we're talking about metals, we think of them as solids, but there are some exceptions to that. And the common exception is mercury, which is Hg. Mercury's symbol Hg comes from the Latin hydrogyrum, which literally means quicksilver. And that comes kind of from its alchemical days. So mercury was known as quicksilver, and it was one of the more important metals in alchemy. So it's been around for a long time and been really important because it's so interesting, right? It's a liquid at room temperature. It's one of two elements that we classify as liquids at room temperature. One of them is mercury, the other one is bromine, and it's one of our non-metals over in the halogens column, which we'll get into in a second. The other thing about metals is they tend to be pretty dense. And when we're talking about density, we're talking about how closely packed the particles are. So how much mass you have and how much space. So we usually say that they're dense or heavy for their size. And this isn't to say that all metals are, because if you think about aluminum, for instance, like aluminum foil, aluminum is not that dense, but this is just sort of metals in general. They also tend to be pretty durable. They stick around for a long time. Now again, this isn't true of all of them, but we think about metals as being durable because we use them for coinage, right? We have coins that have lasted from the Roman Empire on because of their durability. Okay, so that's metals. Now, some characteristics of nonmetals. So this would be everything to the right of our stair step of metalloids. The nonmetals. A lot of these elements that are included in the nonmetals tend to be the ones that we think about in common everyday life. So carbon, for instance, and oxygen, nitrogen. These are all nonmetals. Nonmetals are basically everything that metals are not. So they don't tend to be shiny when they're in their solid form. Their solids tend to be brittle. What we mean by brittle here is, as opposed to malleable, when you smash something with a hammer and it gets thinner and thinner and thinner, then if we smashed a non-metal solid with a hammer, then it would be brittle and shatter apart, okay? Now, another thing about nonmetals is they don't conduct heat very well or electricity, so we say that they insulate. So they're not conductors, they're insulators. So with brittle solids, insulators, they're not shiny, not lustrous. They tend to include things like gases, so we have all three phases for nonmetals. And again, it's just kind of everything that metals are not is included in our nonmetal category. And we get to metalloids then, so metalloids are that stair step, which are also called semi-metals. Then they have characteristics of both. These metalloids can be both metal-like and non-metal-like, so that's kind of how they get classified. Okay, so there's some characteristics. Let's get back to our periodic table here. I want to make sure that my camera is not going to fall off of its precarious perch here. Okay, so I said that each of these columns is a group or a family, and each of these groups has kind of a specific name because of the characteristics associated with the elements within those columns. But there's also another way to group these things, and so I want to give you another indication of that. I'm going to highlight this with yellow. I'm not sure how well this is going to come through. We'll see. This middle bit right here and this bottom bit right here are called the transition metals. And we also call them group B. So again, you can't necessarily see, you can sort of see the hazy outline of my highlighter there. These are called the transition metals, the group B elements. And we're not going to get into in this class a lot of detail about why they're called the transition metals. It has to do with their electron capabilities and capacities. They can actually hold more than one charge for reasons that we aren't going to get into. So we usually say that the group Bs, and you can see the column labels up here, 3B, 4B, 5B, etc. Those are Bs, and then these guys here. This is called the transition metal kind of proper. These are called the inner transition metals because they belong, if you look at this right here, it belongs up here in this part of the table. And then we also have this group of metals over here, which is all of these guys under this stair step. These are all called post-transition metals, and so they're also included in the transition metal kind of qualities, characteristics there. So we have a large group of transition metals within the metal family, right? Because we said everything to the left of the stair step are metals. Now groups 1 and 2, so these first two columns over here, were 1A and 2A, if you look at the other numbering system there. And then 3A through 8A, or 13 through 18, these are all called your group A elements. And they're your main group or representative elements. So the main group or representative elements are the ones that are in 1 and 2 and 13 through 18. And these are the ones that you run into most, at least in our planet and our interactions with the elements. Okay, and some of them have their own specific names. So this first column here that starts with Li, which is lithium, are your alkali metals. That's group 1. The alkali metals include lithium, sodium, potassium, which is K. K is potassium, not to be confused with P, which is phosphorus. So K, which is potassium, rubidium, cesium, and francium. Okay, those are your alkali metals. Group 2 are your alkaline earth metals. My cat wants to jump up, so I'm a little bit afraid. Don't do it, Rhapsody, don't do it. Yeah. Okay, so these are the group 2. Here's your alkaline earth metals. That includes beryllium, magnesium, calcium. Calcium's a pretty common one, Ca. Strontium. Don't do it, cat. All right. Strontium, barium, and radium. Radium is one we're going to talk about later in the quarter. Okay, so here's our alkaline earth metals and our alkali metals. These as a group then, the term alkali or alkaline means basic as opposed to acidic. Okay, so this has to do with these things being parts of basic compounds. All right. Now if we go over to the nonmetals side of things, here's our groups over here. If we look at 6A that starts with oxygen, sulfur, and selenium, these are called the chalcogens. Chalcogens. And as you saw in your reading, so the chalcogens is group 16, these guys here. As you saw in your reading, chalcogens means ore forming. So the oxygen and the sulfur and the selenium, those are all elements that are really important in minerals in the formation of ore. Okay. Group 17 are called the halogens. So the halogens include fluorine, chlorine, bromine, iodine, astatine. So the halogens are some of the more common ones as well. So chlorine is one of the ones, Cl, that you probably recognize. Br is bromine, and that's one of the 2 liquids at room temperature under standard conditions on the periodic table. From your reading, you saw that halogens means salt forming, and sodium chloride, chloride including chlorine there, is actually just table salt. Okay, so it forms salts. Anything that ends with gen, G-E-N like that, comes from the word root genesis, which means creation, as we've seen and heard about. Okay. This last column here that includes helium and neon and argon, krypton, xenon, radon, those are all the noble gases. Okay, the noble gases. And the noble gases were all discovered by a British scientist, and that British scientist found that the noble gases are inert. So the noble gases are all inert, which means that they don't like to react with other things. Inert. Okay, and he said, well, what am I going to name this family of gases after? And he realized that that family of gases, that group, didn't like to interact with the rest of the periodic table. And he said, well, what class of people don't like to interact with the riffraff of the rest of the table? Oh, that would be the noble class. So the noble gases got their name from the fact that this guy was British. The guy who discovered them was named William Ramsay, if you're interested. Okay, so that's a little bit about the periodic table, a little bit about the makeup, kind of a little bit about metals and nonmetals, and we'll kind of get into some more detail on the background of some of the names of the elements in a later video. But this is all for now. If you have any questions, don't hesitate to ask.